Claude Code usually fails because of noise, not a poorly written prompt. As chat bubbles pile up on the left, the clear task on the right gets buried under a layer of irrelevant data. A session pollutes itself through the accumulation of quick questions, side thoughts, and minor corrections. Every "by the way" added to the thread stays in the active context, cluttering the workspace. When the model slows down or begins making basic mistakes, it's easy to assume the AI is broken. This leads many users to spend hours trying to engineer a more complex prompt. The real culprit is the loss of operational momentum. An agentic model requires a high signal-to-noise ratio to stay focused on a multi-step objective. Once that thread is polluted, you end up explaining what you already covered. You spend more time dragging the session back to the goal than you do actually writing code. Keeping an agent moving forward depends on maintaining a clean workflow. A stable, continuous path is the most important factor in whether the model successfully reaches the finish line. Protecting the main working thread requires isolating non-actionable queries from the actual execution path. This central timeline represents active execution. Keep it clean using the sidechannel command /btw. This creates a temporary overlay. Questions are answered without injecting into permanent working memory, preventing conversational drift. Once the node dissolves, the main thread continues perfectly clean. Without a sidechannel, you face a trade-off. You either interrupt the task to get information, or you keep going while the thread grows increasingly crowded with unrelated text. The BTW command has no tool access. It cannot read your local files or write code to your desk. This restriction enforces a necessary split. Use the main thread for action and the sidechannel for understanding. Separating the two keeps the agent's focus on the execution. Most users default to a hard cycle workflow. First they prompt, wait for results, review the output, and then restart the whole session if it's not perfect. It is more efficient to steer the model dynamically. If you see the output beginning to drift while it's running, provide a brief correction immediately. Early adjustments are efficient. By correcting a drift in the first few lines of output, the model pivots using context it already processed. A late-stage restart forces you to discard all spent tokens and pay the full context cost to reload your files from scratch. If the core goal is still being met, guide the agent through the minor errors. A gentle correction keeps the current run alive and prevents the time waste of a total reset. Correcting an imperfect path in motion preserves your context. It ensures the model stays aligned with the project's history while saving the compute required for a fresh start. Steering eventually hits a limit. There are moments where a session has accumulated too much history to be salvaged. You might find yourself correcting the same error 3 times. If the model continues to miss the point or repeats cyclical mistakes despite your guidance, the thread has lost its structure. This repeated failure signals stale context. The weight of previous conflicting instructions is now more influential than your current commands. Continuing to prompt at this stage only layers more debris onto a broken foundation. It is no longer possible to clarify the goal within this specific session. The rule for these sessions is simple. Steer early to keep the momentum, but reset when the context becomes too stale to function. A clean start feels slow, but it stops you from arguing with a model that can no longer hear you. Moving back to a point where the task made sense is the fastest way to get the project back on track. To prevent future thread pollution, move all experimentation out of your main execution lane. Comparing different libraries or thinking out loud about architecture should happen elsewhere. These exploratory thoughts add unnecessary tokens that eventually confuse the agent. Run your tests in a parallel session. Use one thread strictly for producing the result and another for exploring alternatives. Separating these roles protects the execution thread's focus. When the two are kept in different lanes, the workflow remains clean and the agent stays on target. This working model relies on keeping one goal per thread, using BTW for questions, and isolating tests in parallel sessions. Stripping away noise creates a clearer path for the model than a complicated prompt framework ever could. Success comes from the cleanliness of the session, not the complexity of the initial instructions. Adopting these habits reduces drift and minimizes the time spent on repetitive corrections. Ultimately, when the context stays focused on the task, the agent produces more reliable code with less intervention.